In this video we're going to talk about the pH scale as it is applied to acids and bases. I've got part of the pH scale shown here, going from a pH of 5 through to a pH of 9. This isn't the entire pH scale. You can have pHs that go into negative numbers, you can have pHs that go greater than 14. But I've chosen this part because this value right here, a pH of 7, this is representing a neutral solution. pHs which are less than 7 are representing solutions which are acidic, and the smaller it is, the more acidic it is. And I am showing the other side where we have pHs greater than 7, which is basic solutions. And I want us to have a look at how a solution is different when you go from pH 7 to pH 6 or pH 6 to pH 5. The two things which we're going to be looking at, we're going to be looking at the concentration of H+ in these solutions, and rather than writing concentration of H+ each time, I'm going to use the shorthand for concentration, which is a set of square brackets. And I'm also going to be having a look at the concentration of OH- in these solutions, which is represented by square brackets OH-. Don't mix these symbols up with the electron dot diagrams. I'm not trying to represent electron dot diagrams here. The square brackets are strictly for concentration in this case. So we've got our neutral solution, which is pH 7. If we were to have a look at the concentration of H+ and concentration of OH-, we would find that concentration of H+ would be 1 times 10 to the power of -7 moles per litre, or molar. Molar with a capital M is another unit you can use to represent moles per litre. And our concentration of OH- is also equal to 1 times 10 to the power of -7 moles per litre. One key thing about a neutral solution is that the concentration of H+ and the concentration of OH- is the same. That's actually the definition of neutral, when these two ions are in equal concentration to each other. Now let's have a look at what happens with our solution, which is pH 6. The concentration of H+ in our pH 6 solution is actually going to be more concentrated. It's going to be 1 times 10 to the power of -6 moles per litre. And you can probably recognize that there is a pattern between the times 10 to the power of -7 for pH 7 times 10 to the power of -6 for pH 6. So our hydrogen ions actually got 10 times more concentrated going from pH 7 to pH 6. Our hydroxide has actually decreased in concentration. It has gone to 1 times 10 to the power of -8 moles per litre. So during this change, this one got 10 times more concentrated, or put 10 times up, and our base was 10 times more dilute, 10 times down. If we go to pH 5, the same pattern is going to happen. We have concentration of H+, this time will be 1 times 10 to the power of -5, which is a 10 times increase, and our concentration of OH- is 10 times more dilute, 1 times 10 to the power of -9 moles per litre. Going the other way on the pH scale, you should be able to predict what changes are going to happen. In our pH 8 solution, concentration of H+ is going to decrease by a factor of 10, so 1 times 10 to the power of -8 moles per litre, but our hydroxide is getting more concentrated, 1 times 10 to the power of -6. in our pH 9 solution, we now have concentration of H plus equals 1 times 10 to the power of negative 9, and concentration of OH minus equals 1 times 10 to the power of negative 5 moles per litre. So this is 10 times decrease, this one 10 times increase. I mentioned before that a neutral solution was defined as when the concentration of H plus equals the concentration of OH minus. An acidic solution is when the concentration of H plus is greater than the concentration of OH minus. And a basic solution is when the concentration of H plus is less than the concentration of OH minus. So the pH scale is actually helping us to compare how the concentrations of H plus and OH minus differ from that of the neutral solution. And like I said, every one change in the pH scale is actually representing a 10 times either increase or decrease in the concentrations of these two substances. Alright, let's have a look at some more formal details. These are the things that you would need to write down. pH is a measure of the concentration of H+, which is also written with the square brackets. The way that it is calculated is that pH equals negative log the concentration of H+, which is why if I have concentration of H+ equals 1 times 10 to the power of negative 4, that I'm able to go pH equals negative log of this number, and thanks to the way that logs work, that's the way of saying negative 4, which is this to the power of, which is equal to a pH of 4. When you have a high concentration of H+, then you will find a lower pH. If it's a low concentration of H+, you'll find a higher pH. Try not to get those mixed up. People do it every year. You know, we'll say which of these will increase the pH of a solution, and people will say adding an acid instead of adding a base. If it is a pH of less than 7, it's acidic. If it's a pH of greater than 7, it's basic. A change in pH of one value represents a 10 times change in the concentration of H+. So therefore, if you changed 2 pH values, then that is a 100 times change in concentration. 4 values is a 10,000 times change in concentration. So there is a lot of difference between something which is pH 1 and something which is pH 5, okay? And the things which are pH 1 and pH 2, they're going to be the very dangerous substances, whereas your household acids, they're going to be at a more intermediate pH. Given that pH is a measure of the concentration of H+, that means that you can make predictions about pH based on your knowledge of relative concentrations or relative strengths of different substances. For example, if you had 1 mole per litre of hydrochloric acid, which is strong, and 1 mole per litre of acetic acid, which is weak, the hydrochloric acid is going to have a lower pH, simply because it's going to have a greater concentration of H+ ions, being a strong acid. If you had to compare two different solutions of hydrochloric acid, and one was more concentrated and one was more dilute, the one which is more concentrated is going to have a lower pH once again, because pH is a measure of the concentration of H+. If you're comparing some bases, things which produce the most hydroxide ions, they're going to have the highest pH, because the more hydroxide ions there are, the less H+ there will be. What you need to know from this, you definitely need to know that pH of 7 is neutral, less than 7 is acidic, greater than 7 is basic. You need to understand the link between changes in the pH scale and what effect this is having on concentration of H plus and concentration of OH minus, which is what I mentioned with that 10 times increase and 10 times decrease thing. You need to understand that relationship between H plus and OH minus in neutral solutions where they're equal, and in both acidic and in basic solutions. Finally, you might also need to be able to calculate the pH using this formula. pH equals negative log concentration of H plus.